Okay, it's a huge mess now because I'm moving. I got 3 bells here that we brazed up earlier. I just opened them up a little bit on this vise here, just pressed them out so it'd be easier to get under the hammer. So this is my power hammer, and calling it a power hammer is pretty generous. So this has a funny story. Before I had a seam roller, which is that guy in the middle, I had bought a English wheel. Everyone thought I was stupid for trying to roll out seams with an English wheel, but it works out really well. If you want to make bells and you're like, I can't buy a seam roller, and you don't want to hammer seams like an animal, get an English wheel because it'll do it. You got to make a little fixture to keep it centered, but it'll roll out seams beautifully. After I got the seam roller, I didn't need the English wheel anymore, so it went outside. And then I wanted a power hammer. So basically, the power hammer is for the process called breaking the back. And that's what we're gonna be doing first. So if you look at those bells, you see that they're not cone shaped. They're still the shape of the bell pattern, which is kind of like an L kind of shape deal. I mean, I don't even, that's not a good description, but like offset, right? Off center. So we need to make them into cones. So we need to make them symmetrical basically, so that we can open them up and get them onto the bell mandrel. The way to do that is breaking the back, which you bring the pointed part and you basically hammer the back side of it until it's centered. You can do it by hand, and I did for a long time. It's a lot easier to mess them up by hand, and also it's a lot faster using power hammer. Save your shoulder and all that stuff. But so this thing is a monstrosity, but it's awesome. So it's a Harbor Freight English wheel frame. I put this piece of aluminum plate that I just had. That's why it's so large, and it just collects shit. Whenever I need to use the power hammer, I have to clear the stuff off of it. If I had a nice way to cut it, I would have cut it, but so that's bolted to the frame, and then I got this reed pipe vise bolted to that plate and the frame. This rod is a Busher saxophone forming mandrel. Someone I know who did the same thing. This was not my invention idea. I mean, the kind of way it's built is, he did his differently is what I mean. But the ram is a sand tamping ram. It's the cheapest one off eBay. It's like 90 bucks. It's kind of a piece of junk ram, but it gets the job done. Maybe someday I'll find one that works that's not a piece of junk. See the tape on there? So that little end cap is threaded, and the thread is so bad and so loose that I have to have tape there or else it'll fly out. It hooked up to my air compressor right there, and it works. I need a bigger compressor, so it kind of loses power after a while, but it's okay. Good enough for the low quantities that I do. Like, me doing 3 bells on it is a lot. I really only do horn bells on here. Once I start making more trombone bells, which I'm looking to sell more, I will do the trombones on here, but trumpets not even worth the noise, basically, because the trumpet bells, you break it back in like 3 hits. Horn bells, it's a lot more involved. This pattern is much easier than it used to be. It used to be very angled, and it took like 6 rounds of breaking. This I could do, I think last time I did in like 3. So yeah, I'm gonna get the camera set up, and then we're gonna go do that. I'm gonna get my hearing protection. Yeah, I wear hearing protection. That's right, I do that. But you're all surprised. Oh, if you guys want earplugs, you can off. So, the one I just did is on the right. So that's the one I just did, that's the one that hasn't been done yet, okay? This is the difference. So this is what it's doing. You can see the one I just did is standing up like a significant amount straighter than that one. So we're gonna go anneal this one again. We're gonna finish the rest out off camera, but then we'll keep annealing and keep hammering until it's standing up perfectly like that one. This one's already done. This is an 020, not an 016. You can see it's pretty drastic how much that one's standing up. Well on its way to being a cone. I see all the wrinkles are getting planished out. And none of those are folded, those are just kind of raised above the general surface, and they all get ironed out. Pretty cool. So I just did the second or maybe third, I don't know, Colin, figure it out, round of hammering on the hammer, and I'm about to anneal them again, but you can see they're already much more less bad shaped and more better good shaped. We're gonna get the torch and start shooting with some fire. That's it. That's how you do that. You don't heat them up like fucking bitch crazy, because then you melt them. But you don't even want to get it close to the point where you melt it. You just want to use gentle heat. Because this is the type of thing that is just, it does not make any sense to try to do it in an oven. Because when you're making a bell like this, you need the tail section of the bell to stay harder than the flare you're working. Because if the whole thing is soft, the bell would collapse in your hands while you're going in the hammer, because you need to put a bit of pressure. When you're using a torch to anneal, you just got to be really careful on where you're putting your heat and how much heat you're putting into the part. I've seen some people not even burn shit, but like they way over anneal stuff. And the fact of the matter is, you do not want the metal you're working, at least for musical instruments, to be dead soft. You lose all the ductility of it, and it just turns into a wet noodle. And I'm sure there are things that happen in the grain structure too, and I know I have a couple friends who get into that stuff, but I just look at it as when it's past the point of being annealed, way over annealed, it's very hard to work with. I'd rather it be not half hard, probably quarter hard or eighth hard or something, because half hard is how you get it from the mills. Really ductile, because you want that workability. You want a little bit of resistance when you're moving the metal, but you don't want it to spring back. We'll go hammer again. Now that we've got them pretty good, I mean, I could take another 2 rounds to keep hammering on them, but what I'm going to do is, since we haven't rolled the seam yet, these have to get flattened out anyways. So there's no sense of making them perfect cone, because pushing them through the steamroller is actually going to help us break the back a little bit. So I'm just going to take this bell and put it on the mandrel we're going to be drawing these down to. And I'm just going to slap this down and then hammer this back on the mandrel, get it pretty coned. And then once they're all like that, we'll flatten them down, put them on the stakes, and go through the steamroller, and we'll show you that. It's pretty cool. So this is the mandrel we're going to be getting these down to. Like I said, these are Vienna horn bells. So this is the mandrel that I made here in my shop, based off of an original. Ullmann is the name of the maker, who, from my understanding, I deal with people who understand this stuff better, so they just tell me, and they send me horns to copy, and I just copy them. So I'm not really a historian on it all, but from my understanding, he invented the Vienna horn and the pumping valves. So this is an earlier one, so it has a tighter throat. Richard Serafinoff's let me borrow the horn to copy. It's an original from like the 1840s, I want to say. So we're gonna take this bell on the mandrel we're gonna spin it down to and just give it some slaps. The thing you're gonna want to watch out for, because this end is coming this way, it's gonna want to bunch up here. So what you do is just do it partially, and then you iron out these ripples here before they can even have a chance to fold over. It could be a little tricky, you just gotta be careful. I'm gonna have to take these on the post anvil and get that out before I keep going, but back in a second. So I just hammered those creases so that they wouldn't have a chance to form. You can get them out once they are rolled over, but it's a pain in the ass. I just, at this point in my working career, or whatever the fuck you wanna call it, I just scrap the bell and start over. Because even if they crease over so, and you hammer them flat so that it's just overlapped, you can cut them out and re-braze them, and then hammer them down flat with the thing. You can see on a bell if it's had a braze repair. I will only ever do that with bronze. There's companies out there that do that with silver, and I think that's sketchy. I honestly won't sell a bell if it has a braze repair. And I don't sell B-stock because I don't think it's a good look for someone to buy a B-stock bell, even if it's like for an aftermarket Bach or something. You don't want that out there representing the quality of the bells you make if it's something that has weird sanding lines or scratches or a bad bead or something like that. You just don't want it out there. So that all goes in the scrapyard. That's all she wrote. We'll grab the other one. Cool. That's it. That's all you do. We'll take this on the post anvil and we'll just smooth out any creases, and then we'll flatten them down and get them ready to roll. Just by doing that, you can see how much more cone shaped they are. Pretty cool.
Steak, bitch.
Just after stomping them on the mandrel, I'm gonna take them on here, iron them out, get all the wrinkles off, get them ready to roll out. This is a nylon hammer. You know it's nylon because when you hit it against steel, it doesn't explode like Delrin does. This is from Harbor Freight. It was like $4, and it's the best one I've found. So now that I'm talking about it, I roll bell seams now, but every once in a while you have to touch them up with a hammer, and this is also from Harbor Freight. And it's the best ball peen hammer maybe not construction-wise, but the feel of and the weight is the best I've used. So, and I've spent some big money on some hammers, and they all suck. So we're just going through, and anything that would have the chance of getting overlapped when we're rolling it, which is a lot of stuff has a chance, we are gonna iron out now. So the trick is for this, when you have like a sharp peak of the brass like wrinkling out, you want to lift it off of the mandrel. Because if you're just banging on it when it's tight to the mandrel, then nothing's gonna happen. So you want to lift it off of the mandrel, give somewhere for the material to go, and then hammer on top of the crease, and that'll give it somewhere to flatten out. Switch to my rawhide hammer. There we go. Add it to the stack. I think we got one more somewhere. Yeah, this one's gonna be fun. good to me. So you can see how pretty close to cone shaped it is now. So we'll roll it out and then we'll open it back up and start inside spinning, which is the most fun part.